So you know that feeling when you're not going to have time to do Advent of Code that day until the evening, and you log on to your morning stand-up, and you're like, "Oh, have you done it yet?" And your colleague's like, "Oh yeah, it was easy today. Yeah, much easier than yesterday." And then the fear strikes you. What if, what if today's the day? What if today's the day that I mess this up? Um, yeah, so, oh gosh, okay. So many links. So apparently it's easy today. Let's hope. Otherwise, stand up tomorrow is going to be a riot. So we've got, it's a different sort of input this time. We've got this string, and our job is to find the first occurrence of four unique characters. So this one doesn't count because it's got two J's in it. This one doesn't count because it's got two J's in it. This one doesn't count because it's got two Q's in it. This one doesn't count because it's, well, actually, this one does count. So this one's, actually, no, it doesn't. The most recent four characters. Oh, yeah, okay. So the right one is, yeah, JPQM. Yeah, so this is the one we want. And we want to get the number, like a number, in this case, the last letter number, or like really kind of after. So this, if this is 0, 1, 2, 3, 4, 5, 6, 7. So there'll be 7 characters before we get to this one. So anyway, so we've got to be right at the end of here. So we want to get that number, and we've got a few other examples here. So we've got 4 here. So here it's like, well, who cares? We don't need to do this. We can do that on the Excalibur, but here's the thing. All of these inputs, don't they just look a little bit short and easy? Yeah, well, of course, the actual input is a much longer string, so we do have to be probably not super careful about performance, but we have to maybe be a little bit wary. And it's just sort of interesting because we could just see it here. Maybe it'll be this string here. Maybe it'll be that TMCJ. Wouldn't it be cool if it was TMCJ? If it is, that would be good, right? But it's not, because it's going to be SCFZ. That's what it's going to be. Anyway, those guesses aside, so that's what we've got to find out, and maybe we can start to look a little bit ahead to the step 2. So step 2, here we've got 4 characters. 4 characters that are all different is what we're looking for. What if could it be 5, 6, 7, 20 characters? Maybe that's going to be the new window. So we might want to think a little bit ahead about that, just to try and predict the future. It's probably not going to be that, but if it is, then we may want to prepare for it. So this one is in the danger zone for me, because it is seemingly quite straightforward in a way that I can sort of see a solution that would work. And then I get bored and I think, well, is that really the nicest solution? Maybe there's another solution maybe there's a clever way of doing this, but I'm not going to do that this year. I'm going to go with the simplest possible solution, see if I can, well, just not screw myself over by picking really sort of weird ways of doing things. So let's copy these sample inputs in here and see if we can develop a algorithm to solve this challenge. Okay. So So let's say, let's pick the one that comes first to my mind. We go through character by character, or rather, we go through by index. If the 4 chars before index are okay, like so, if we are less far through than 4, we move on. If we are if the last 4 chars are all different, we return this. We return the index. So let's go through this. Let's go through the first example. Okay, so we start at 0, which we skip under rule. We skip under rule 1. 1 we skip under rule 1. 2 we skip under rule 1. 3 passes. So it's really it's like if index is under 3, so that's the rule there. Then when we get into 3, we start to take the last 4, which in this case is MJQJ. Next one down is, okay, JQJP, QJPQ, JPQM, PQMG. And I think we don't need to go any further. So we then want to work out, are all of these different to each other? And so we've got a condition here, which is it's something like well, I can think of a kind of iteration way of doing it, but it's really like, is M the same as J? No. Is M the same as Q? No. Is M the same as J? No. Is J the same as Q? No. Is J the same as J? Yes, in which case we're done. So we're going through item by item and comparing it to all the items afterwards. So for this, I'm sure, you know, if we uniqued on this and then checked the length, then we could do that as well. That probably wouldn't be so hard. Or we could put them in a set and then check if the size of the set was the same as the, it's just a kind of gross way of doing it, isn't it? Okay, here's what I'm going to do. I'm going to have a function called is all distinct. And I'm going to encapsulate within that the logic of checking whether every item in the list is unique. And I'm going to do it an ugly way first, which is I'm going to work out how to unique on a list in Python. I'm going to research that. Then if this needs to become more efficient in some way, or if that even is inefficient, I don't even know, but I do know that I could do it in an efficient way. And I could probably do it in an even more efficient way if I really anyway, that's what I need to not do. Then in any case, I can encapsulate within this is all distinct, or at worst case, I can try to find a fancier way of doing it in the second step. I don't need it now, that's for sure. So is all distinct, which is going to do that logic magically. False, 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 true. And then this gets us JPQM6, which needs to become 7. Because we are, it's after. So this gets us an algorithm that seems to function and will function in long ones. It's in terms of the number of operations it's going to need in the most efficient case, it's going to mean, so each loop round is going to be, it's going to be 3 times 2, so 6 operations, because MJ, MQ, MJ, JQ, JJ, QJ. So six possible 6 operations to check one round. So it's going to be 6 times worth of the length of the string, which is going to be how many operations it's going to take. So it's really the window factorial, so or window -1 factorial times the length. Well, I just put brackets everywhere. Very silly. So if the window, so this would be, if the length of the string is however long that is, I can't do any coding to find out. So let's say it's really long, maybe 1,000 characters. If it's 1,000 characters, that's going to be 6,000 operations. If we increase the window to, let's say, 10 characters, it's going to be 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2. And that's going to become a lot of characters. It's going to become a lot of operations. So that's something to watch out for if it's in step 2, if the window increases to some ridiculous number. Do I want to try and check? Do I want to see if I don't think I'm going to see what happens if that needs to change, but I am sort of aware of it as a problem here and something we might need to change later. Of course, it's probably going to be something totally different now. So in terms of my program plan, I'm going to need to have a is all distinct. I'm going to need to have a sort of windowing thing, which I will is any or first distinct window. I thought about getting fancy there with like a generator or something, but I'm not going to do it because I don't need to. And a main loop, which I naturally probably not going to need really at all because it's just one long string. So that's it really. So in terms of a plan of action, it's going to be right is all distinct, right first distinct window. Okay, seems straightforward enough. Let's switch over to VS Code and get started. Or actually, I think I am going to, no, I mean, I don't think I need to work through another example actually. Maybe one more. So NZNR, ZNRN, RNFR, NFRF, FRFN, RFNT. That's right. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it should be 11. And it is. Okay. So that anyway, I'll stop over egging it. Let's switch to VS Code. Get my time. Now, actually, I'm going to do this research first. Python unique list. Okay, so you convert it to a set, basically, and then we can compare the length. And if the length is the same, fine. Easy. Okay. I'm going to get the input first, and I'm going to copy it into this file, but I'm just going to paste this in actually. I'm not going to do any file reading. And I'm going to also paste in some like the sample lines that I've got here. Okay. All right, let's get started. Okay. No. All right, ignore that. Let me just check I'm not getting any weird stuff here. Okay. Just ignore Copilot interfering there. Nice. Okay. Okay. Hmm. Ah, I'm screwing up here. I don't think I know enough Python to do this. Print too early. Why am I returning at this point? Oh, why is chunk turning out to be C? All this. What have I done wrong here? Oh no, it's empty. Okay. We're returning before we get anything. One, two, three. MJQJ, that's right. JQPM. So what's this coming out as now? Or you won't print anything at all? Okay. Okay, I'm definitely getting confused now. 8. That's why. Should be 7. Okay. Oh, that's why. Okay, so this one's not. Six, and this should be, oh no, this should be, yeah, the one starting with B needs to be 5. The one starting with N needs to be 6. And we've actually got so the one starting with N, the one starting with 5, the one starting with B should be 5. And we've actually got 6. So this one, okay, fine. All right, I'm just cutting that off too early. I really want, yeah, that's what I really want. Yes. Okay. My God. Okay. Now, if the first one is okay, so this one, yeah, and then we get all the way to this one, and that should be the last one. So if so let's say this one should be 4. Okay, let me make this, let me get this sorted. Okay, 5. So this one's 5. No, wait. Yeah, this one's 5 because the first one's number 5. So this one should be 4. But it's not coming out as 4 for some reason. It's coming out as none. And the reason for that is okay, that's good. And if we add 1, 2, 3, 4, 5, should be 9. Okay, perfect. All right, I think this, though it has taken me a comically long amount of time to get here, is the right algorithm. So let's try it with the real one. I have to print it, of course. 1640. Okay, let's try this out. Okay. Wow, that took me much longer than it needed to, just because I was messing around with those indexes and everything. Okay, I need to watch for that in future. Where there's an index heavy problem, I need to get those index sorted up front. Okay. And probably work out how to make it more obvious when I'm making these mistakes as well, what sort of logging I need to do. All right. Startup message marker. Okay, your device's communication system is correctly detecting packets, but still isn't working. It looks like it also needs to look for messages. A startup message marker is just like a startup packet marker, except it consists of 14 distinct characters rather than 4. Here are the first positions of startup message markers for all of the above examples. Yeah, 14, a 14 character window. As I suspected. And actually the set code may not behave so poorly actually, because it'll probably allocate, it probably won't need to compare everything against everything else. So actually the set code is probably better than my factorial comparison. Because you could use a hash table for that one. And then sum the keys. It's probably something along the lines of what it's doing. Anyway, we can look at that. So 14 character window, which we find, oh, okay. Oh, by the way, was my, no, I was nowhere near. Okay, so after character 19, so in this case, we've got, let's look at this one. So the answer is after character 19, which is this one. And it's a 14 character window. So that would be, we work out 14 characters long. That's 15. This will be 14. 1, 2, yeah. So 19, that's all right. So that's between a character. Brilliant. Come on. Let me get this a little bit nicer. Okay. So if I write out and then I put 1 against M, 1 against G, 1 against B, 1 against L, 1 against J, 1 against S, 1 against P, 1 against H, 1 against D, 1 against Z, 1 against T, 1 against N, and 1 against V, we end up with no duplicates. So one way to do this in a nicely performant way would be to create a dictionary of letters to numbers and increment each item, or go through the list of characters and then add 1 to every item in there, or even just add to a hash, a key, kind of as we don't need to create them up front. And then if we find a key that already exists, then we know we've got a duplicate. Yeah, that would work. Still, we should probably find out what the performance characteristics of Python sets are. You always find me at my lowest, realpython.com. Okay, brilliant. Well, it can't be that slow because yeah, it's going to compute a hash of the element anyway, or well, I guess we'll find out, won't we? I guess we don't get to know. This looks pretty promising though. Okay. Anyway, so I think our approach will work fine. If it doesn't, then we've got an approach where we've got a backup approach. Oh, okay, don't want that. We've got a backup approach of go through each item in the window, add it to a dictionary with the key as char, check if there is such an item in the dictionary. If so, not distinct. If we get to the end, we're distinct. Okay. And other than that, it's essentially the same deal as before. Okay, I think let's go. So my plan of action is going to be 1, copy over code from part 1, 2, try just changing the window size. You win. Otherwise, implement like re-implement using dict strategy. Okay, all right, let's get started. Timer. Okay, actually, let's get our asserts working. And let's ignore that one. Okay, so in this case, we would like to replace all do we want to just try this? No, let's just try it. So it's going to be 14 rather than 4. Oh, it's just 4. Oh gosh, why am I even subjecting myself to this? Okay, well, that was pretty quick. Let's try that out. 36, 13. 36, 13. Perfect. Well, that was pretty much I've got 28 minutes 46 seconds, which was you know, just over a minute, and most of that was probably muddling around anyway. So that brings us to the end of today. I guess it wasn't so challenging, was it? at least not for me. If it was for you, I'm sorry. That's the end. See you for the next one.